So the whole idea behind operator overloading is to implement the built-in operators for our classes. In this lesson, I'm going to show you how to implement the equality operator, and we'll look at the other operators over the next few lessons. So first, let's add a new class here called length. Now in this class, I want to add an attribute called value. So value of type integer. Now let's generate a constructor to initialize this attribute. So if you're on a Mac, press Command and N. If you're on Windows, press Control and N to bring up the generate palette. And here we generate a constructor that takes the value as a parameter. Let's go ahead. So here's the definition of the constructor in our CPP file. And in our header file, we have this constructor declared as explicit. Okay. Now let's go to our main file. On the top, we're going to include the length header file. Now let's create two length objects. So length first, and we're going to initialize this with 10. And one more time, length second. Now I forgot a semicolon over here, so let's add that. Good. Now currently we cannot write an expression like this. We cannot compare two length objects. This is where operator overloading comes to the rescue. So here we can implement the equality operator in the length class to allow two length objects to be compared for equality. And that is super easy. So back to our length header file. In the public section, we're going to add a new function that returns a Boolean because the result of this expression is a Boolean value, right? So this function returns a Boolean. Now the name of the function is operator followed by two equal signs, okay? Now, because this function is part of this class, here we have access to the first length object. So that is going to be the first object or the object on the left side of the equality operator. So we only need a parameter for the object on the right side of the equality operator. So over here, we add a parameter of type length called second or other, whatever you want to call it. The name doesn't matter. Now, for performance reasons, it's better to use a reference parameter here. And here we should also make this a constant parameter so we don't accidentally change any values in this object. Now, by the same token, because in this function we are not going to change any values in the current object, we should mark this function using the constant keyword. So here's our function declaration. Now let's generate the definition. Good. Now here we should write an expression like this. So we're comparing the value of the current object with the value of the other object. Now we can go back to our main file and write an expression like this, okay? Now, there is something I need to clarify here. This operator we defined here is just a function, just like other functions we have declared so far. There is nothing special about it. So we can call this function just like other functions. So here we can write an expression like this. We can write first dot operator equal and pass the second object. But obviously, this syntax is kind of verbose, it's too noisy, so it's much easier to write an expression like this, okay? Now, what if you want to compare a length object with an integer? So can we write an expression like first equals 10? Currently, no. And the reason for that is because our constructor is declared as explicit. So in this case, the compiler is not able to implicitly convert this number to a length object. And currently we don't have an operator that takes a length and an integer. But we can easily solve that problem by overloading this operator one more time. But this time, instead of passing a length object here, we pass an integer object, okay? Now, in this case, we don't want to make this a reference parameter. We should only use this technique with our custom types, not primitive types in C++. Because primitives are small and there is no performance gain in passing them by reference. So a very basic declaration. Now let's generate the definition. Now over here, we're going to write code like this. If value equals other, then we return true. And now with this, we can compare a length object with an integer, okay? Now, when we implement the equality operator, modern C++ compilers automatically generate the inequality operator for us. So we don't have to explicitly implement this operator. But if the compiler you're using doesn't generate this operator, you have to explicitly implement it in terms of the equality operator. Let me show you what I mean. So here we add another operator. This time it's the inequality operator. Now again, we can have different types of parameters here. We can pass a length object or an integer. For this demo, I'm going to go with an integer. Okay. Now let's generate the definition. Now, in this function, we are not going to write code like this. Why is that? Because if in the future we change the logic for comparing two length objects, we have to make changes to several functions. We have to change both the equality and inequality operator implementations. So a better way to implement the inequality operator is to implement it in terms of the equality operator. So we can rewrite this expression like this. First, we compare the value with the other value in terms of equality. At this point, this function will get executed. Now, whatever this function returns, we simply invert the value. So we are implementing the inequality operator in terms of the equality operator. Now, CLion is giving us a warning and saying this expression can be simplified. But if we go ahead and simplify this expression, we go back to our previous implementation. So don't always follow the suggestions of CLion. So I'm going to revert the code. Now, as your exercise, I want you to define a class called point with two attributes, x and y. Then overload the equality operator for comparing two point objects. So spend a few minutes on this, then come back see my solution. All right, I'm going to go through this real quick because the steps are very repetitive and I don't want to waste your time by a lot of typing. So I'm going to add a new class called point. Here we need two attributes, x and y. Next, I'm going to generate a getter and a setter for these attributes. I'm going to select both of these so we generate the getters and setters in one go. Good. Now, we also need a constructor for initializing these attributes. So one more time, I'm going to generate a constructor that takes these two values. Good. Now, back to the point class. I'm going to do a bit of consolidation because CLion has added multiple private and public sections, and this is ugly. So I'm going to remove the second public section. So now all the public members are next to each other. I also like to put all my getters in one place and all the setters in one place as well. And finally, I'm going to move all the public members up here so they are listed before the private members. Great. Now we need to add the equality operator. So a function that returns bool and takes a constant point as a reference. And we should mark this as constant as well. Now let's generate the definition. Now here we check to see if x equals other.x and y equals other.y. Now to improve the readability of this code, I prefer to wrap each condition in parentheses. Good. Now let's test this. So we go to our main function. First, we import the point header file. Now I'm going to create 2 point objects. First, with these values, and second with the same values. Now let's see if first equals second. Now, because the priority of the stream insertion operator is higher than the equality operator, we need to wrap this in parentheses. Now take a look. So we see 1, beautiful. But if I change one of these values, we should see 0. Lovely.